Hi, my name is Keenan Hardert. I'm a biology professor at Minnesota State University, Mankato. I study cancer research and education research. So today we've got some data up here from some of my education research, and we are going to perform a Poisson regression where we're going to take different counts of data, specifically in this case, what I've got highlighted here in reviews that are kind of non-normal, basically. The reason that you use Poisson instead of multiple linear regressions in this case is that we're going to be able to see when data starts kind of at zero and then is going to kind of keel off to the rare events, like a histogram like that. And these have to be whole numbers and they can't be negative. So we're going to be able to kind of learn about the model, the coefficients, some of the ratios. We're going to be able to see how well the model predicts the actual data, expected versus observed, and go from there. We'll also see, and as you can see on here, we'll be able to compare our dependent variable against categories like low and high, like you see, and other data like this. So let's go ahead and get started. As you can tell, I've got some data in here. This is from the other tutorial series, but here for each row is a student. Here's the number of hours they worked. Here's the numbers of hours they spend in athletics, performance, or ROTC. There's their daily commute. Then we've got three pure category variables for if they failed or passed the class, whether their employment was above 20 or not. And if they attended the class 90% or more, then you got a high. Over here, I actually also have the raw normal percents for these, but we'll find that Poisson's pretty good because the data is not needed to be assumed to be normal, because this is basically the probability of events over a fixed period of time, but it doesn't need to be that perfect histogram like we usually see. So the hours data, the APR data, the attendance data are not really normal data. The class percent data is pretty normal, like a little histogram in the middle, like where everybody's at. But let's go ahead and see what happens here. So with the results, you want to click on New Analysis. You want to go over here. Actually, doesn't have its own name. You got to find multiple linear regression, and you are in multiple variable analyses right here. So I want to include everybody. That's going to be good. I'm going to hit OK. And right here, you want to go ahead and click Poisson right there. Okay. All the Y values, subjects, events, perfect. What I want to know, I'm going to compare everybody against the dependent thing that I want. For my research, I actually want to know how do the factors influence together the number of reviews that students attend. Because I'll tell you right now, most of them are at zero, then quite a few go to one, quite a few still go to two, and then it kind of tails off into the really rare events. We'll be able to visualize that too. Next thing that you want to do, if you do have some categorical variables, like I do have attendance, employment, and class result, you do want to give it a reference for what direction you want to kind of say, what's my expected outcome? What's my control, essentially? So in this case, I'm going to say, well, attendance, I actually would expect to be high. Employment, I would expect to be low. And result, I would expect them to pass. So let's go ahead and see everything here. The rest of the setup is probably going to be pretty good to just leave on default. Okay. So, and like other similar videos, you can do two-way interactions. Let's just start with regular right now. So we go ahead and hit OK. Now, the good thing here is that this is going to kind of set up our data right here and say like, hey, what is the thing that you are comparing all of these sets against, right? So the intercept itself is simply like the model. So that's not strictly like a variable. That is everybody's influence in on one thing, essentially. But what I really want to see is, depending on the number of reviews students go to, how much do hours essentially, like what is the beta value? What is the like predictive value on a log mean scale, at least in this case for Poisson, for how much hours estimate to move review numbers? So these values right here, because it's Poisson, are on a log scale, but they can still be interpreted as kind of directional movement and predictive value on the regression. So if I look at, for example, right here, something like this might be a good sanity check. Attendance has a positive influence on number of reviews. That would make sense. The class percent actually has a highly significant, even though it looks like a small number, look at that 95% confidence interval. That's really tight right there, and it's really positive, right? So that's saying the class has a beta value that is predictive of more reviews, that positive. Now, let's look at our first categorical variable, and I can do all these together. If you are failing, you are reverse. you are in the reverse essentially of number of reviews. So I don't want to use the word inverse correlation. That's not what's happening, but there is a predicted value that it would go down when these two are against each other. We actually find that if you just simply subcategorize employment as a high thing, and it's just a blank 20 hours or not, it's actually pretty predictive that they would go to more reviews. So that's actually pretty encouraging. Same over here. We got some other good stuff right here. Even commute ended up pretty small significance right here. So looking at everything in our ratios right down here, we also have multicollinearity right here. I want to point this out though, that this VIF number right here actually is kind of saying, okay, are some of these factors actually pushing and influencing the other ones? The reason these numbers are so high right here is that, yeah, by putting in attendance as a category variable and then also having it over here as a percent variable to kind of show everything for us today, they are going to kind of push each other's buttons a bit. So if I go over here to covariance and I find my way to, let's see, beta 4 is attendance and beta 8 is, yeah, beta 8 is attendance itself. Yeah, if you categorize things based on a high and a low cutoff, then the raw numbers will also like kind of influence each other. So given that, that's why just for this example, I probably would not, I would have chosen maybe one of those instead. But in this case, it still kind of goes to show how the data can kind of work for you. So there's our multicollinearity. You also should, if you only use linear data as well, you'll probably find a stat test that will ask you, hey, these are normality tests. And if you're using Poisson data, you actually would expect non-normal data, and you would see a significance in those non-normal tests. They aren't here with us because we did too many categories in this case. But where this all shines is that this first figure that we get is actually a combination, again, with the other factors. Here is the number of reviews that were true for all the students right here. But based on all the factors and the predictive values assigned to each one, we can actually make a predicted how many reviews they theoretically should have gone to. So we actually see a bunch that went to no reviews, but based on the other circumstances, there's a few in here that actually should have gone to maybe 4 or 5 reviews. See those guys right there? We also see there's the extreme right there. Like I promised you, here are the extreme ones that are going to like 20, 21, maybe even 15, 14 right here, that they were super extreme in real life. And their stats alone would have had them maybe be like, yeah, maybe only 4 or 5. Especially this one right here is really like had a ton of review visits, but their statistics otherwise would not have predicted that. So residuals, just like the old stuff, how far were you off on the model, essentially? Were you off in the negative direction from the predicted value? Were you off in the positive direction? The only thing right here that's different with this homodicity plot is that this is an absolute value. So the negative values that you just saw in the last plot are simply called how far away were you from the model? That's that. This is pretty neat because again, you can zero in right here and say like, hey, there's row 76. I want to see why they were so far off. And that's kind of a neat way to kind of look through stuff. If you did have your data ordered, it can go like this. I actually did have my data ordered based on class performance. So these were actually the lowest performers over here to the highest performance over here. So by actually inputting the data that I had in a setup right here. So see how class is already set up in row number to go from lowest to highest. Look how cool this gets, that actually my model's a better fit for down low. So I am more, I'm kind of looking at this on my own, but the model kind of expands as I was like, hey, as you do better in class, it didn't seem to matter about review visits for residuals. So kind of maybe a sad truth about teaching, we'll see. So here's that collinearity plot that we talked about. This was that table that we saw before, and that's where I showed you like, yeah, total raw attendance versus the category high or low of attendance is super influencing each other's variance. Again, if I re-ran this test, I would probably maybe just choose one category variable and get rid of this right here. So if I want actually, you know what, let's just go ahead and do that. I'm going to go ahead and do this really quick right here. And then I'm going to say, hey, can you, I think it's, yeah, so it got mad because I took away one of its variables. So let's go ahead and run one more. Multiple, no more attend percent in this case. I want my reviews to be the dependent. No, I got to do my reference levels again. Oh, that's okay. And again, reference levels will always go to that first level, but you can say custom and say, hey, here's what I want you to make this on. All right, so if we look back down at those VIF numbers now, they're a little better. There we go. They're a little better down here. They're not all at 2.0. Ideally, you want them around 1 theoretically because you don't want them to be hyper correlating with the others. But these normality of the residuals as well also came through like we talked about. So now if I look at parameters, like we said, these numbers are not sort of off the charts, although here, well, there's the intercept right there. I'm trying to look around there. There's one beta 1 and beta 4 hours in employment. Yeah, again, two things. Yeah, I should have deleted one of those too. But regardless, you've got a really good setup here. And where the key power of this is going to be is if, and again, like for my research, this is important because the number of reviews that students go to is highly helpful data, but it starts at 0 and most of them go to 0. I want to see how is that going to predict which factors are going to be pushing that number of reviews and how do they kind of relate with one another. So given everything, again, the Poisson is something that is very good to use when that lambda is sort of that really low number close to 0. And we can go from there. But yeah, thanks so much for listening again.